Students, welcome to Sunil's tutorial. I'm Sunil Brahmani and today we'll be doing this chapter called as correlation. Let's see this. First question. Find Carl Pearson's coefficient of correlation. Right, they give you data x is 65, 66, 67, 67, 68, 69, 70, 72. Y is given to you as 67, 68, 65, 68, 72, 72, 69, 71. Now, how do I find this? First thing, the largest number here in x column is 72. The smallest number is 65. Take a value between 65 and 72. Say, take a mean value between them. Let's assume I take 68. So I'll say u is equal to x minus 68. Right? So 65 minus 68, that is minus 3. Minus 2, minus 1, minus 1, 0, 1, 2 and 4. Then V. Smallest value is 65. Largest value is 72. Take a value in between that. So let's assume if I take say 69. So in that case V will be 67 minus 69. Minus 3. Minus 2. Minus 7, 8, 9, yeah, sorry. Minus 2, minus 1, minus 4, minus 1, 69. So 3, 3, 0, 69, 2. Right? Find out u square. 9, 4, 1, 1, 0, 1, 4, 16. Find out v square. 4, 1, 16, 1, 9, 9, 0, 4. Find out uv. 6 minus 3 into minus 2, 2, 4, 1, 0, 3, 0, 8. Right? You are multiplying uv. Add these columns. Right? You have to add all the columns. Right? When you add this, you will get this as 544. Right? When you add this, you will get this as 552. U, when you add this, you will get this as 4, 5, 6, 7, 3, 5, 6, 7, 0. This is 3, 6, 8, 8 and this is 4, 5, 6, 7, 8, 0. And u square, you will get this as 36. V square you will get as say 44 and uv you will get as 24. Right? You have to find out Carl Pearson's coefficient. Carl Pearson's coefficient R is given by the formula n times sigma uv minus sigma u sigma v upon square root of n times sigma u square minus sigma u the whole square into n times sigma v square minus sigma v the whole square. Right? N is the number of terms. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms. Right? There are 8 terms. So n times sigma uv. Sigma uv is 24 minus sigma u into sigma v. 0 into 0 upon n square root of n times 8 sigma u square 36 minus sigma u the whole square 0 the whole square into n times 8 sigma v square. Sigma v square is 44 minus sigma v the whole square 0. Right? Now this is going to give you, when you solve this, you will get this answer as 0.6030. right? So do you understand how to find out Carl Pearson's coefficient of correlation? This is how you get Carl Pearson's coefficient of correlation. Now I'm going to put up a couple of sums where I want you all to see this method and solve a couple of sums, right? Let's see another sum. Find Carl Pearson's coefficient. They've given you the data as x and y, 8, 10, 15, 17, 20, 22, 24 and 25. This is 25, 30, 32, 35, 37, 40, 42 and 45, right? So when you solve this, look at the previous sum, solve it exactly like the previous method, you should get your answer. You should get this answer as R should come out to 0.98, right? I'm going to show you one sum and I'm going to give you a couple of sums for practice. Let's see this. Another sum. Find Carl Pearson's coefficient. X and Y, 10, 12, 14, 18, 20, 16, 20, 18, 15, 13, 16, 10, right? Same method, same logic, use everything same, you should get the answer. The answer for this should be negative 0.5976. Next, another sum. Find Carl Pearson's coefficient. X and Y. X is given to you as 5, 10, 5, 11, 12, 4, 3, 2, 7, 1. Y 1628, 514, 652. Right? Same logic again, we should be able to get this answer. The answer for this sum should come out to 0.5750. Right? Next sum, another sum for practice. X is 2, 3, 5, 6, 8, 9. Y is 6, 5, 7, 8, 12, 11. Find Carl Pearson's coefficient. Should get the value of R as 0.9303. Right? So I think I've given you sufficient sums for practice of first time. Now let's move on to the second time. They will give you find Carl Pearson's coefficient, where n is given to you as 15, sigma x is given to you as 175, sigma y is given to you as 280, sigma x square is given to you as 2150, sigma x square is given to you as 2150, sigma y square is given to you as 6225, and sigma xy is given to you as 3500. They've asked you to find out Carl Pearson's coefficient. In fact, they have eased the matter for you. Instead of uv, you will use xy. So you can say R is equal to n times sigma xy minus sigma x sigma y upon square root of n times sigma x square minus sigma x the whole square into square root of n times sigma y square minus sigma y the whole square. This is n is given to you as 15, sigma xy 3500 minus sigma x 175 into sigma y 280 upon square root of n times n 15 sigma x square 2150 minus sigma x 175 the whole square into n times 15 sigma y square 6225 minus sigma y 280 the whole square, right? Substitute the values. When you substitute the values, you will get this answer as, solve the equation, you should get this answer as 0.7095. Fine, do we get this in here? So another method, instead of using UV, you can use XY and solve the sum. Except that wherever there is U, use X, and wherever there is V, use Y. Next, let's see another sum. Find Carl Pearson's coefficient for the following data. N is given to you as 10, sigma x minus x bar, y minus y bar is given to you as 90, standard deviation of x is 3.56 and standard deviation of y is 2.86. Right? They've asked you to find out Carl Pearson's coefficient. Here, when standard deviation is given, you will have to use a different formula to find out Carl Pearson's coefficient. In that case, Carl Pearson's coefficient will be given by the formula R is equal to sigma x minus x bar y minus y bar upon n times deviation of x into deviation of y. This is another formula to find out Carl Pearson's coefficient when the standard deviation is given to you. So this is 90 upon n is 10, standard deviation of x 3.56, standard deviation of y 2.86, right? Divide this data. So in that case you will get this as 90 upon 101.816. So you should get this answer as 0.8839. That's how you get Carl Pearson's coefficient. Next, another method to find out Carl Pearson's coefficient. If they give you the data, find Carl Pearson's coefficient. Sigma x minus x bar y minus y bar is given to you as 105. Sigma x minus x bar the whole square is given to you as 146, and sigma y minus y bar the whole square is given to you as 170. Right now, here they haven't given you standard deviation, but they've given you the square of the mean difference. In that case, I can say that R is sigma x minus x bar y minus y bar upon square root of sigma x minus x bar the whole square into square root of sigma y minus y bar the whole square. That's another formula to find out Carl Pearson's coefficient when the data is given to you in this manner. Right? When you solve this, this is going to be 105 upon square root of 146 into square root of 170. So this should give you 105 upon 12.083 into 13.0384. So when you solve this, you should get this answer as 0.67. That will be your Carl Pearson's coefficient. Right? Next, let's see another type of sum, guys. Find number of observations. We give you sigma x minus x bar y minus y bar is 102, sigma y minus y bar the whole square is 72, standard deviation of x is 5, and correlation coefficient is 0.5. Right? R is also called as correlation coefficient. Now, since standard deviation is given to you, you will have to use that formula of Carl Pearson where you have standard deviation. So you will say R is equal to sigma x minus x bar y minus y bar upon n times standard deviation of x into standard deviation of y. But we know from our standard deviation that standard deviation of y is nothing but square root of sigma y minus y bar the whole square upon n. I can substitute this value in the above formula, in which case I'll get R is sigma x minus x bar y minus y bar upon n times standard deviation of x into square root of sigma y minus y bar the whole square upon n. Right? Cross multiply. So I'll get R n standard deviation of x into square root of sigma y minus y bar the whole square upon n is nothing but sigma x minus x bar y minus y bar. R is given to you as 0.5. N we have to find out. Standard deviation of x is given to you as 5 into square root of 72 upon n is equal to 102. The first thing I need to do is get rid of the square root side. How do I get rid of the square root side? By squaring both sides. 0.5 square will give you 0.25 into n square. 5 square will give you 25 into square root, and square will get cancelled. So 72 upon n is 102 into 102. N and square gets cancelled. Therefore I'll get n is 102 into 102 upon 0.25 into 25 into 72. Right? Solve this equation. When you solve this, you will get the value of n to be 32. So the number of observations are going to be 32. Right? So do we understand? How do we get Carl Pearson's coefficient? Let's see a couple of more sums for practice. Find Carl Pearson's coefficient. Right, Carl Pearson's coefficient. They've given you that the value of n is 10, sigma x is 100, sigma y is 150, sigma x minus 10 the whole square is given to you as 180, sigma y minus 15 the whole square is given to you as 215, and sigma x minus 10 y minus 15 is given to you as 60. Right? Now, let us assume, since they've given you x minus 10, so let us assume that x bar is 10 and they've given you y minus 15, assume y bar is 15. In which case, I can use the formula R is equal to n times sigma x minus x bar y minus y bar upon square root of, not n times, this is just sigma x minus x bar y minus y bar upon square root of sigma x minus x bar the whole square into square root of sigma y minus y bar the whole square. Fine, do we get this thing here? Substitute the values. In this case, you will get this as x minus x bar y minus y bar is 60 upon square root of x minus x bar the whole square 180, square root of y minus y bar the whole square 215. Solve the equation. When you solve the equation, you will get the value of R, that is 0.3049. Fine. I think we've done all the sums using Carl Pearson's coefficient. Right? Right. We'll stop this here for the day. Thank you very much.